Hello everybody. So today I start with a new topic, that is simultaneous linear differential equations with constant coefficients. So this comes under unit 1. Okay, so we have completed 2 units. So one is a partial differential equation, and there we had formation of partial differential equation, then solution of Lagrange's equation, and then non-linear first order partial differential equation, then Charpit's method, okay, and then we have a solution of linear partial differential equation with constant coefficients. So all these we have studied in these 2 units. Next, in the unit 1 we are having simultaneous linear differential equation with constant coefficients. So that means here 2 simultaneous linear differential equations are given, which are of first order, which are of first degree, okay, first degree, and we have to solve those equations. Okay, so now there is no derivation or directly we solve the problem. So example 1. So it is given that solve the system of simultaneous equations. Those are given as dx by dt plus 7x minus y equal to 0, and dy by dt plus 2x plus 5y equal to 0. Okay, so this is a given problem. So here 2 simultaneous equations are given, 2 simultaneous differential equations are given, which are of first degree. So these are given, and we have to solve these 2 equations for x and y. So now call this equation as 1 and this is equation as 2. So solution. Next, in this case, let us denote, let d by dt is equal to d. Okay, for our convenient, let us denote d by dt as capital D. Now we are replacing here. Therefore, equation 1 and 2 becomes, with this substitution we get dx plus 7x minus y equal to 0. So this is first equation. In this you can take x common. We get d plus 7 into x minus y equal to 0. Correct? In the same way, we substitute d by dt as capital D in equation 2. So we get dy plus 2x plus 5y equal to 0. Or this implies here in this and the first and third term we take y common, which implies d or 2x, okay, d plus 2, d plus 5 into y plus 2x equal to 0. In the first and the third term we take y common, okay, we take y common in the first and third term. We take y common, then we get d plus 5 into y plus this 2x as it is equal to 0. Okay, so now we got two simultaneous equations. So now this is equation 3, call this equation 3, and this is equation 4. This is equation 4. So we got two equations, that is d plus 7 into x minus y equal to 0. Okay, equal to 0. So then d plus 5 into y then plus 2x equal to 0. These two equations we got now. So now we solve just like solving a simultaneous equations, simultaneous simple equations, just like 2x plus 3y plus 6 is equal to 0, then 6x plus 2y plus 4 is equal to 0. So this is a very simple, these are the very simple equations which you have solved in your SSLC or 8th, 9th in your primary school. Okay, so I hope that you remember these techniques. So what you have to do in these cases, so what you will do in these cases, suppose you want to eliminate, you have to eliminate one of the unknown, either x or y. Okay, you have to eliminate either x or y first. So to eliminate x, so if I want to eliminate x, I should make the coefficient of x same in both the equations. So here I have the x coefficient as 2, and in this case I have x coefficient as 6. So I should make the coefficient of this x same. So what I do for that, I multiply the first equation with 3, so that when we multiply this equation with 3, then this becomes 3 into 2, 6. So this is also 6, and this coefficient of x is also 6. Okay, so while multiplying this 3, remember that if you multiply this 3 with this 2, then you should multiply 3 to all the terms of this equation. Okay, so whatever the multiplication number you choose, that you have to multiply with all the terms in that equations. Okay, so then you will eliminate, change the sign, and then you eliminate, and you will find the y value. After finding the y value, you substitute the y value in any of the two equations, and you will get the value of x. So the same procedure you have to apply here. Okay, so in the same way here, what we do here, d plus 7 into x minus y equal to 0, and d plus 5 into y plus 2x equal to 0. Now these two are two simultaneous equations. Okay, so I have to eliminate one of the unknown, either x or either y. Okay, so suppose that I want to eliminate y. So what I should do? So I have to make the coefficient of y same. So here the coefficient of y is d plus 5, and here the coefficient of y is 1. That means here I should make the coefficient, means I have to multiply this with d plus 5. I have to multiply the equation 1 with d plus 5. I have to multiply this equation with d plus 5. Okay, so then what we get? So d plus 5 into d plus 7 into x. So I have to multiply this term with this equation. So means I have to multiply each and every term of this equation with d plus 5. Then minus d plus 5 into y equal to 0. Next thing is, write the second equation as it is, d plus 5y plus 2x is equal to 0. So now draw a line, then this d plus 5, this is plus and this is minus, you add these two, so this is plus and this is plus, so this d plus 5 minus d plus 5 get cancelled, and if you add these two, you will get d plus 5 into d plus 7 into x, d plus 7 into x, then plus 2x is equal to 0. Adding these two, we get this equation, and these two terms are cancelled because they are of opposite and the same terms. So we get this equation, d plus 5 into d plus 7 into x plus 2x equal to 0. Now I multiply these two terms. So this is d square, d into d square, then plus d into 7, that is 7d, plus d into 5, 5d, plus d into 5 into 7, that is 35, into x plus 2x equal to 0. Or we have d square plus 7d plus 5d, it is 12d plus 35 into bracket x plus 2x is equal to 0. Or to take 2x in this term and take x common, so d square plus 12d plus 35 plus 2, it is 37x. So from these two terms take x common, so 35 plus 2 gives 37 into x equal to 0. Okay, now this is a simple ordinary differential equation. So okay, now we find the auxiliary equation is, for this auxiliary equation is, so this is m square plus 12m plus 37 equal to 0. Now on solving this equation, so either you apply minus 3 plus or minus formula or any other factorization method, so then we get m is equal to, and solving, m is equal to minus 12 plus or minus square root of minus 4 divided by 2, or this is simplifying, we will get minus 6 plus or minus I. So two roots will get, so therefore hence the solution is, the two roots are complex, which are of the a plus ib form, right? So we'll get the two roots as m1 is minus 6 plus I and m2 is minus 6 minus I. The two roots are complex, so therefore the solution is, the general solution is x is equal to, when they are complex, e raised to alpha x, alpha means minus 6t into bracket c1 cos t plus c2 sin t. Okay, this is x. So this you have learnt in your 4th semester. Okay, this you have studied in your 4th semester, ordinary differential equations. So just refer the 4th semester book and you will find such type of equations, and you have this method. General solution is obtained by e raised to alpha x into c1 cos t plus c2 sin t. So this is the general solution. Okay, now we got x value. Next is we have to find the value of y. Okay, we have to find the value of y. So to find the value of y, again taking the given equation. So what is, now taking the given equation. So what is that equation? First equation we have b plus 7 into x minus y equal to 0. Correct? So this is a given equation. Now from this equation, y is what? This implies y is equal to, send this y to that side. So y is equal to d plus 7 into x, or y is equal to dx plus 7x. Correct? Okay, so now we got the value of x. This is x. Now substituting x in this equation, that's all. So now substituting x, so this is equation in y is equal to dx plus 7x. In this equation we have to substitute the value of x. So that is, y becomes d of x means e raised to minus 6t into bracket c1 cos t plus c2 sin t plus 7x. Correct? Next, y is equal to, now we have to differentiate these things. So here c1 is constant. Now here we apply product rule. So first e raised to minus 6t is, keep it as it is. Differentiation of cos t is minus sin t. So I have written minus here, minus sin t. Then plus c1 constant, second term as it is, differentiation of e raised to minus 60. So here this is minus 60 into e raised to minus 60. Okay, applying the product rule, differentiation of these two will get. So this is equal to 7x, or y is equal to, simplifying this, we get here from this equation, this is c1 e raised to cos t plus c1 cos t e raised to minus 60 plus 7x, and one more time this also we have to differentiate. Okay, this we forgot to differentiate here. So that is plus c2 constant, then e raised to minus 60 constant, differentiation of sin t is cos t, then c2 as it is, again keep sin t as it is, then differentiation of minus 60 is minus 6, here it is minus 6 into e raised to minus 60. Here these two signs are minus because e raised to minus 60 is there. So on differentiating this you will get minus sign. So this is minus and this is minus 6 c2 sin t e raised to minus 6 t equal. So this is y value. On simplifying this, y is equal to, we will get taking e raised to minus 60 common, and in bracket we got c1 plus c2 cos t minus c1 minus c2 into sin t. So wherever cos t is there, so take cos t common, wherever sin t is there, take sin t common, and in both the terms again e raised to minus 60 we will get common, so take that outside, so we will get this equation. So this is y. Okay, so we got both x and y value, and these are the solution of the given simultaneous equations. Okay, so with this I conclude this class and continue in the next class. Thank you.